All right, hey everybody. So in this video, what we're going to be looking at is actually some formulas from our formula sheet that you guys will have access to anytime you're working in this class or like on an SOL. You will always have access to the formulas. So you do not need to memorize any of these formulas. No, you don't need to memorize them. Chances are you'll have a lot of them already memorized from elementary school just because you've seen them so many times. Or you might have them memorized by the end of this video because again, you just might be looking at them a lot. For this video, we care about the distance around the 2D figures. And off to the side, I'm going to mention that you've heard this called perimeter, but you've also heard it called circumference, okay? You've heard it called perimeter and circumference. Now, perimeter is just something that goes around a polygon, and then circumference is the word we use for circles, okay? So these are the two words. And I can kind of get away with it if I just say the distance around the 2D figures, because that's the definition of perimeter. Again, perimeter goes around a triangle or a square or a rectangle. And then we use the word circumference for same thing. It's just now you know you're going around a circle, okay? All right, on the formula sheet, we can, for today, we're not going to pay attention to area or area. We're going to pay attention to the perimeter and then these circumference formulas. And when we have to go around other weird shapes like these first two, I'll just point out that it's okay if you don't see a formula. You can straight up just add the distance around the numbers, or I mean around the shape. So this first shape, we've got here, 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 and here. Doesn't really look like it's drawn to scale because if this is a 5 and that's a 6, obviously it's not drawn to scale. Doesn't really matter though, because for the distance around it, I'm just going to take this 6, and that's a 12. I got top and bottom. And then my 5s, I'm just going to add those up. So the distance around here, I get a 22 inches. Okay. For this, we do not need the 4. The 4 is just there to kind of distract you in this problem. We would use the 4 for another unit for area, but we're not going to need that for right now. So part of this video is actually learning what you do need versus what you can ignore for certain problems. Now for a triangle, to go around it, we've just got this one plus this one plus this one. I see 3 sides. The 9 measures this, the 6 measures this, the 13.7 measures that. So we just add them all up. 9 plus the 6 plus 13.7. Cool, 28.7 centimeters. Since we're just going around it, notice that I'm just labeling it with centimeters. I'm not doing square centimeters or anything fancy, just straight up what I see. All right, so if I'm trying to go around this rectangle, we do have a formula. And if you're feeling fancy, like you want to gear up for algebra, let's try to practice this. It's saying twice the length plus twice the width. Okay? Now, the length is the 8. So it's just saying you're going to have 2 of those 8s, which is the top and the bottom. And then it's saying you're going to have 2 of the widths, which is the 3. It's the same thing I did up here, y'all. You might remember that I just did 2 times the 6, so I got that. It's the same as doing 2 times the 8. Okay, so here we get a 16 for the reds. And then over here I did the same thing. I did like the 5 and the 5 and got my 10. So 2 of my 3s here is a 6. And this just happens to be coincidence that we get the same answer as we did for the one up above it. That is totally a coincidence. And this one we get 22 centimeters. Okay. Now, if you're not feeling fancy and you don't want to put it into the language of algebra, you could just be like, all right, I got an 8 plus 3. Now 8 plus 3 is 11. So I could double that and get my other 2 sides. That would work as well. Now the circles right here, let's review why we see 2 formulas. And let's review the words diameter and radius. So in this, I'm actually given a radius, okay? The radius is half the diameter. So the radius in this case is a 4. If I asked y'all what the diameter was for this circle, and I know this isn't in your notes, you can just write it off to the side. The diameter is if it's going all the way across. So the diameter here would be an 8. Now that's why we actually have both formulas up here. You'll notice that in this one, it says 2 pi r, and this one just says pi times diameter. They're the same thing because twice the radius, the 2r, is diameter. So they have two formulas here, just so that you don't get confused. It really just depends on what you see in the picture. In this picture, since I'm given the radius, I'm going to use the formula 2 pi r. It reminds you that you need to take that 4 and double it for the circumference. So 2 times 3.14 times 4. So the 2 times the 4 is the 8. We know that. And now I'm going to do times 3.14. And I get a 25.12. So the distance around this circle is 25.12 inches. Friendly reminder that for this one, I'm technically putting that perimeter equals. For this one, I'm technically putting perimeter equals. For this one, I can put perimeter equals, but now because I'm dealing with a circle, that's why you see the circumference. Now the one right below it, do y'all see how the line goes all the way across? So I'm using the diameter. So this one, we can just say, all right, I've got the diameter. I don't need to double anything. I can just plug in the 21. And now we'll use the calculator to do 3.14 times 21. And we get a 65.94. And this is miles. So we've got the circumference of this one. So if they give you the radius, friendly reminder that you want to use 2 pi r to remind yourself that you really care about the 8. But if it already gives you the diameter, you can just use that formula. And that kind of clarifies why we see these two things here. And now for the last one on this page, distance around this right triangle, we can just add them up. I've got a 5 plus 1 is 6. And then 6 plus 5.2 is 11.2. So that one I don't even need the calculator for. All right, we're just going around the triangle, I mean. All right, cool. So now let's flip over. And I think the previous part was some stuff you've already seen before. Now let's kind of apply it to some shapes that look a little bit weirder, okay? So for this one, if I'm trying to go all the way around this shape, I've got an 8. Now this one right here, there's no number by it. But right here, it's labeled as a 3. And you might remember that these little tick marks let you know that all these sides are going to be a 3. Okay? So anywhere I see that, and I'm going to make them all in red just so I don't forget. Boom, boom. Here's another one. Here we go. And then let me change the color of my 8. Let me just erase that one real quick so it stands out. Cool. So for the red, we've got this 3 plus this 3 is 6. 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So the red part is 24. Yes, there's a shortcut. You could have just been like, well, if this is 6, I could say 6 times 1, 2, 3, 4. So yes, we've got that distance. Now we can't forget about the 8, the 8, the 8, and the 8. So 1, 2, 3, 4 of those things is going to be 8 times 4 is a 32. When we add these up, we get a 56. And so the distance around this shape is 56 inches. You could just go the long way and just start from up here and say, okay, I've got 8 plus 3 is 11, 12, 13, 14. Then you've got 14 plus 8 is 22. 23, 24, 25, 26, 27, 28. Now 28 plus 8 is 36. 37, 38, 39, 40, 41, 42. Now 42 plus 8 is 50. 51, 52, 53, 54, 55, 56. So no matter how you want to think of it, the distance all the way around this shape is 56 inches. Now for this one, we've got the distance around, we've got a 16, we've got a 10, and a 5. So I'm going to write these down so I don't forget. We've got a 16, we've got a 10, we've got a 5, we have a 3, we have, a number I don't know that I'm going to fill in right here in a second. We've got a 2, we've got a 6, and we have the 9. So we have almost all of these numbers in red that we can add up. We just need to find this blue missing side. Now to find the blue missing side, I'm going to point out that up top we have a 16. And I can move this right here. And I can take, let's use purple. I'm going to use purple for this one. Then I'm going to use green for this one. If I move the purple up, that was 6. Okay, see how the bottom is 6? So here it's a 6. And see how the green's 5? If I move it up, that much is 5. So we said the green part was 5. We said the purple part was 6. And the whole entire thing is 16. So 6 plus 5, we have 11 so far. So if we have 11, this has to be a 5 because 11 plus 5 gives me the entire thing of 16. All right, well, if that's a 5, so I can move the 6 back down. I've got the 6. I'm good there. 6 plus 5 is 11. And now 11 plus this 5 right here would have given me my whole 16. So this is a 5, and I'm just going to fill it in right there. And now I have all my numbers to add up in the calculator. So I'm going to start with this 16, and I like to just go clockwise. So 16 plus 10 plus 5 plus 3 plus another 5 plus 2 plus 6 plus 9. Oh my gosh, did it happen again? Look at that. We had the same answer. That's totally coincidence, y'all. So the distance around this is 56 feet. That is super coincidence that it's the same answer as this one. That's a super big coincidence. And it's even more of a coincidence that it happened here and here. All right. Okay, cool. So you've got the distance around kind of these weird shapes. Sometimes you might have to find one of the missing lengths. That's not a big deal. All right. And then if there is a missing side, like one of these down here, you can still find the perimeter. You just might need to use the Pythagorean theorem. So if you have a missing side of a slanted side, we can still find the distance around it. We just need to use the Pythagorean theorem, okay? So for this one, I know I've got a 12 and a 20. So far, the distance around in red, we've got that. But I don't know this thing here in purple. I don't know these purple sides. So I can figure them out. See how I've got a 10 here as my height? See how I just created a right triangle? So the height here is a 10. I've got one of my legs. Now I can actually figure out this other leg. If this part in green is 12, I'm just going to move it down. So the green part is a 12. Now the whole thing's got to be a 20, okay? Let me drop this and get another dotted line. Okay. So if the green part here is 12 and the whole thing's supposed to be a 20, the difference is 8. So the 8 has to get split up for this to be the 4 and the 4. So now 4 and 4 is 8 plus my 12, the whole thing across is a 20. Now the Pythagorean theorem says if you have 2 legs, you could do 10 squared plus 4 squared. And when we do the 100 plus the 16, we can take the square root of the 116, and we found our purple side. So 116, when I take the square root of that, I'm going to round it to a 10.8. Okay, 10.8. This 7 is going to bump that up to a 10.8. All right, so if the purple part is 10.8, and there's 2 of them, I've got a 10.8 that I'm going to add, and another 10.8 that I'm going to add. So I taught you guys how to use the Pythagorean theorem, okay? Previously, I already taught you how to find, doesn't matter what shape I give you, what right triangle, you've got the Pythagorean theorem to find a missing side. So you're going to use that tool now here to say, okay, I'm going to find the missing side of this thing, and then I can come through and find perimeter. The 12, we've got our two 10.8s, and then the bottom all the way across was this 20. So let me take care of the 10.8s. I got two of those. Now I'm going to add the bottom 20. Now I'm going to add the top 12. We get a 53.6 for this one, a 53.6. And it's feet. So 53.6 feet is the distance all the way around this trapezoid. All right, now if I have a triangle again, and I want to know the distance around the triangle, I got to figure out this side right here. The good news is we have a right angle, and we've got both legs. So it should be pretty simple to just do the 4.5 squared plus the 6 squared. We'll need a calculator for 4.5 squared. All right, so 4.5 times 4.5 is 20.25. And then we know 6 squared is 36. So I'm going to add a 36 in the calculator. Cool. And we get 56.25. And when I take the square root of that thing, I found my hypotenuse. All right, so we get a 7.5. So we know this side is 7.5. So now we're going to add 7.5 plus 6 plus 4.5. So I've got the 7.5 plus 6 plus 4.5. And the perimeter around there is an 18 inches. So in elementary school, perimeter seems pretty easy. You just add up all your sides. And now you're learning how to link the Pythagorean theorem to that concept of just adding up all the sides. And now for one final problem, a semicircle is what we call half a circle. So for the semicircle, I don't want the distance all the way around the circle, okay? I only want the distance around half of it, and then I got to take care of the 6. So I care about this thing right here. Okay, I care about this part. So if the distance around the whole thing is pi times diameter, and that's on your formula sheet, friendly reminder in case you forgot, you've got a circle. The distance all the way around it is pi times diameter. I've got 3.14 times my diameter. My diameter here we said was a 6. And that would actually get me all the way around. But I don't want to go all the way around, y'all. I only want half of it because I only want half the distance around, okay? So I've got the whole circumference, but I am cutting it in half. So 3.14 times my 6, this would be the distance around the whole circle. That's the whole circle. I don't want to go all the way around the whole circle, though. I only want to go halfway. So let me show you guys. I'm not going all the way around, and I don't need the diameter labeled anymore. I'm only going halfway. So I'm going to cut that in half. So this part is 9.42. The curvy part is 9.42. This is 9.42. So the curvy part is 9.42. So I just did half the circumference. That's all I did, 9.42. Now the catch is, if I'm trying to go all the way around this shape, I got half the circle, but now I do want to trace the 6. So I'm going to add the 9.42 plus the 6. And we get 15.42. So 15.42. I don't have anything labeled, so I'm just going to put units. 15.42 units. So again, circumference in blue, it would have gone all the way around the circle. But I cut it in half, so it's just the green part. Okay, so it's just the green part. So I've got that part, great. But I can't forget about tracing that. So I've got the 6 that I also need to include. And that is my entire distance around right there, 15.42. You guys are going to get some practice now in the packet, and then there's going to be some work online after this. But that concludes this video. Thank you for watching.